Hey everyone, William Spear here with Autodesk, and today I'm going to show you how you can go from Revit Direct to CNC. So that's how you can take elements from a Revit file and export them out of Revit and get them ready for fabrication by CNC, computer numeric code, automated cutting, and what have you. And the purpose is really to get your antenna up to the fact that it is possible to go from Revit directly out to CNC. For today's video, what I'm going to be using as an example of that is how to export out JIP wallboard from Revit to CNC fabrication. Basically how to slice up a wall, get the wallboard to show, cut it, and then send it out for fabrication. Before we get started, one of the things I want to point out, anybody that's used to using Revit, especially Revit MEP, and has ever laid out duct or piping or any of those types of system families, knows that when you run them through a wall, they don't actually cut the wall. But if you look here, you can see very clearly that I've got wall openings in here, right, where the ducts pass through and where the pipe openings are over here. So naturally, your question is going to be, well, how on earth did you do that? Well, I'm really glad you asked that. It's a great question. So the way I did that was by turning to a third-party tool called Cut Openings, and it's made by Tools for Revit. So it's TOOLS 4, the number 4, and REVIT, all together is one word, .com. And that actually took me to this page this time, which is aga-cad.com. So I guess maybe they've merged since the last time I looked here. But the tool I needed was Cut Opening. And in this case, they now have Cut Opening free. So if you select that link and you scroll down to download the free product, it'll take you to a page where you can fill in your credentials, click send, and they'll send you a free download of that tools for or cut openings, right? Um, if you want more than the cut opening free, you can come to this page where they offer the regular cut openings for purchase and even have cut opening pro. Although this link I couldn't get it to work, you can come here nonetheless and check and see what's available in each offering, right? But this is where I got what I needed to cut those openings that you see here. Okay, and when you download this and install it to your computer, what they'll give you is an extra tab here, Tools for Revit tab, and what you can see is that they have the interference check data, insert MEP openings, modify the openings, upgrade, and help, and so on. All right? All right, so that's how I got these openings in there. So let's focus now on how you get the actual JIP wallboard out of a standard wall in Revit. So first of all, what you want to do is you want to come over here to the properties, and where it says show original, change that to show parts. And when you do, you can see this wall down here on the left has actually now revealed that there's the core and the two JIP wallboard panels on it, whereas this wall on the right still looks like a regular Revit wall. Well, the reason for that is I went and parted this wall out so that when I show parts, these appear. I haven't parted this wall out yet, so let's do that. So we'll select the wall, come up to Create, Create Parts, and voila. Now that wall is parted out. So if we look at this in elevation now, you can see right away that I've got the JIP wallboard panels created over here, whereas over here it's still one monolith, one long big piece of JIP wallboard. So how do we get that converted? So I created just some line work in a Revit family file. So I created what I called a 4x8 panel array, and all it is just line work that I spread out at 4x8. You can create a more distinguished family if you like. You can add some parameters to it so that way you can actually drive the width between each line and the height between them. So if you have 4x10 panels, you just change the number and it automatically adjusts. So you can get as snazzy with it as you like, but this is all I needed for my purposes just to demonstrate this to you. So with that placed, now we'll select the wall and we'll use the Divide Parts tool up here, edit the sketch, and simply select, in this case, the Pick Lines tool. And I'm going to pick the lines that actually will then cut the JIP wallboard on this side of the wall and say finish the edit and finish the sketch. And then we'll take this guy here and we'll hide him. And voila, you can see that now I've got distinct wallboard panels here with the openings cut in them, with the sizes that they need to be, and so on. All right? So we've gotten all the way from standard walls in Revit now to where we have gyp wallboard panels that are cut and ready to be exported. But here's where I ran into some shortcoming. This is the one shortcoming in this process that out-of-the-box Revit couldn't resolve for me. So if we go to an elevation or plan view, let's go to plan view and isolate just the gyp wallboard. If I go and select the gyp wallboard for export, let's look at it in a 2D view or 3D or isometric view so you can see this. And we come up here to the application menu and export and CAD formats. If you know anything about CNC, you know the one we want is DXF, because any CNC machine in the world can accept the DXF file, right? And I select go, I say, okay, let's export that. What I'm going to get is a single DXF file with all these panels in it, which is not what I want. I don't want all these panels. So in other words, if I just selected 20 panels, I would get a single DXF file with 20 panels all kind of glued together in it, which isn't going to do it for me, all right? So I needed a way to get all 20 panels out, or whatever I selected out, as individual DXF files, but do it all in a single operation. So enter Jeremy Tamik into the picture. If I select these again, we'll go to an isometric view again so you can see them all. And now come up to my add-ins tools. Here's where you can see the tools that I developed with Jeremy, that he wrote for me and we put together, that are not tools that are out of the box by Autodesk. These are not offered by Autodesk. They're not for sale, but I'm happy to give them away to anybody that would like them. I'll see if I can post them to the actual YouTube video as collateral, but if not, you can certainly email me. I'll give you my email address at the end, and I'm happy to give those away to whoever would like them. But what this DXF tool does is it allows me to, in a single operation, select where I want to save them to video and say OK, and out they go, and that's how long it takes. So now these are developed as DXF files. So if we go to Explorer and take a look, there they are. So here are the 10 panels that we took out. And notice too, before I take these out, that the naming of them, we also covered that, and when we exported it, Jeremy put this in there. So the naming convention is going to be that it picks up the level from Revit that it came from. So this was on level 1 in Revit. This is the unique ID code for the parent file number. So in this case, it's the wall that Revit that we took it from, and the underbar and the child, basically the number of the part that we created. So when we cut it up, this is the part number, and each one of these is unique. So it's a very unique naming convention. That way you don't have any duplicates, hopefully. All right. So let's take these, and we'll drag these down to AutoCAD so you can see them. This is not necessary, but at least you can see them here. So it's still Revit to CNC Direct. And these are now going to open up so we can view them. And let's look at a couple of these. So this happens to be the panel where we had those 3 pipes going through. What's the business value of this? Well, first of all, when you cut these by CNC, you're not measuring out in the field, and you're not trying to cut and rough cut out in the field. With a CNC machine, it's very accurate. It already has the dimensions directly from the model. And using the cut openings tool or other tools, depending on how I decide to open or actually create the hole, maybe by void, I'm going to set the diameter on this. Let's say it's a 3-inch pipe going through here. I can set the diameter to 3 1/8. Why? Well, by doing that, what ends up happening is I end up with a 1/16 inch of a gap all the way around that pipe, meaning that there's going to be less fire stopping or caulking, what have you, that's going to be required to fill that hole. So I'm going to use less materials. It's going to be more accurate. Basically, anybody that's out in the field as a fabricator can really just become an installer at this point, because this is going to show up in the field with these holes cut, or in the case of some of these other parts and pieces here with these openings in them already done with a barcode label on it. You scan it with your iPad with BIM 360 field. It tells you exactly where that piece goes. All right, so there's some really cool business value to this. It's dead on accurate, it's clean, it's fast, and so on. All right, let's go back to Revit and cover one more aspect of this. One of the other things that we wanted to do in presenting this would be to really give you some neat tools, parameters that are already put in there for you. So if you come up to schedules here, let's open the part schedule and the material takeoff schedule. And you'll notice that what we can bring out of this, what the information and metadata we can glean from this is obviously the count, the material area of each panel and its total, the material name, the length, the width, and so on. And that's for the takeoff schedule. If we look at the parts schedule, we have a little bit more in here, the original type, the material, again, the length, height, area, and even volume. But what's really cool is we decided to add a couple of date categories. So we have CNC Fab Export first and CNC Fab Export last. So here's the first and last date that any of these items were exported. And we've even color coded it so that if it has been exported, you can see it in red, with the goal being to actually see that discretely as a discrete color in the plan view, which I haven't gotten to yet. I haven't figured out if there's a way to do that. But if you figure it out, email me. Let me know what you came up with. All right? So that pretty much covers it. What I wanted to do was more or less just get everybody's antenna up to the fact that it is doable. You can go from Revit to CNC by using a DXF file format, which any CNC machine will accept. The only other thing that I'm hoping will happen, I have no idea whether Autodesk has any plans to do this or not, but if you agree you think this would be cool, get on the blogs and on the Idea Station and let your opinion be known. But what I was thinking is, just like we have a control here to show parts, what if we had intrinsically the spacing for gyp wallboard built into Revit, and all you do is go over here and identify what width and height you want, and automatically these adjust, but you never see it until you actually turn on show panels or show gyp wallboard, and then you can see the actual spacing and maybe slide these around to adjust so that they're cornered or justified the way you want. But I thought it would be cool if we actually had that intrinsic or native to Revit. So if you think that would be cool too, by all means, start making your requests known. I think this would be a useful tool for any subcontractors so they can do takeoffs and fabrication a lot easier directly from Revit. All right, well, hopefully you found this video helpful, and thank you for joining us. We'll talk to you soon.